centricity or eccentricity. Here it is. Conic is the set of all points P of the form xy in a plane such that the ratio of the distance from P to a fixed point and the distance from P to a fixed line is constant. Well, a picture will help illustrate this. What you see here is the shape or a piece of a conic section, and it doesn't have to be any one particular conic. But in this picture there's a focus and a line. The line is the directrix. This point is the focus. The eccentricity or eccentricity is the ratio of the distance from the point to the focus to the distance from the point to the directrix. Well, let's look at how that applies to an ellipse. This particular ellipse has eccentricity 1/4. Remember that an ellipse has two foci. Notice how close together those foci are. This ellipse has eccentricity 1/2. The foci are a little further apart. If the eccentricity is 3/4, the foci are even further apart. Well, let's find an eccentricity given an equation of an ellipse. What we're going to do is find the eccentricity of the ellipse, whose equation is given by 12x squared plus 9y squared equals 36. We need to divide every part of the equation by 36 to get x squared over 3 plus y squared over 4 equals 1. Now 4 is a squared, so a must be 2. And keep in mind, I'll write it over here, eccentricity is the ratio c to a. Well, I have a, I need to get c. For an ellipse, recall that c is the square root of a squared minus b squared. So for this, the ellipse, the amount c is the square root of 2 squared minus b squared, which is 3. The square root of 1 is 1. So the eccentricity of this ellipse is 1/2. Let's look at eccentricities of other conic sections summarized here. A parabola has eccentricity 1. An ellipse, eccentricity c over a, and that amount has to be between 0 and 1. A hyperbola has eccentricity c over a, and the eccentricity is greater than 1. We can use this information to come up with an equation of a conic section. Let's do that. What we want to do is write an equation for each conic, and we'll start with this one. Each parabola has its vertex at the origin. Each ellipse or hyperbola is centered at the origin. Well, the particular conic whose equation we're looking at here has eccentricity 1, which means it has to be a parabola. So we know automatically its vertex is at the origin. If its focus is at 0, 8, that means the parabola opens up. And so we'll substitute information into the equation. X squared equals 4cy. C is the distance from the vertex to the focus, or 8. So x squared is 4 times 8 times y, or x squared is 32y, which could also be written y equals 1 over 32 x squared. Well, let's try another. In this particular case, the eccentricity of the conic is 1/2. That means we have to be working with an ellipse, eccentricity between 0 and 1. And keep in mind that the eccentricity is the ratio c to a. If it, as indicated in the instructions for the problem, if we have an ellipse, the center is the origin. If one focus is at 3, 0, that tells me that the amount c for the ellipse is 3. So setting up a proportion, I can say 1 to 2 is 3 to a, and I can find a. By cross-multiplying, I see that a is 6. If I'm going to write down the equation of this ellipse, though, I need b also. I know b squared is a squared minus c squared. So b squared is 36 minus 9. So b squared must be, let's see, 36 take away 9 is 27. So this particular ellipse with center at the origin is x squared over 36 plus y squared over 27 equals 1. Well, in this lesson we've summarized conic sections. Be sure to work lots of exercises from your textbook for practice.